Mathematics Chapter 1 Patterns in Mathematics. What is mathematics? Mathematics is a large part the search for patterns and for explanation as to why those patterns exist. Now over here on the screen you can see that there are different patterns around the earth and in different parts of the universe. And why these patterns exist is the study of mathematics. Such patterns indeed exist all around us in nature, in our homes and schools, and in the motion of the sun, moon and stars. They occur in everything that we do and see, from shopping and cooking, to throwing a ball and playing games, to understanding weather patterns and using technology. So we use mathematics in different things. The sun that we see in the sky, the moon and the stars all have mathematics in them. The games that we play and the weather patterns that we see around and the technology that we use all have mathematics in them. The search for patterns and the explanation can be fun and creative endeavor. It is for this reason that mathematicians think of mathematics both as an art and as a science. This year, we hope that you will get a chance to see the creativity and artistry involved in discovering and understanding the mathematical patterns. So over here, in this year, that is in 6th standard, we will learn different forms of mathematics but in patterns and shapes. It is important to keep in mind that mathematics aims to not just find out what patterns exist, but also the explanation for why they exist. So in mathematics, we will also be very curious about to know why these patterns exist. Such explanation can often then be used in applications well beyond the context in which they are discovered, which can then help to propel the humanity forward. For example, the understanding of patterns in the motion of stars, planets and their satellites led humankind to develop the theory of gravitation, allowing us to launch our own satellites and send rockets to the moons and Mars. Similarly, understanding patterns in the genomes has helped in diagnosing and curing diseases, among thousands of other such examples. So recently we have seen that people are sent to the space, outer space, using the concepts of mathematics. You have seen recently that there were 7 ladies who were sent in the outer space using the recent technology and also mathematics. Also, we can find out that using this mathematics, we can diagnose and cure different diseases. Now there are some questions for you all. Figure it out. Can you think of other examples where mathematics helps us in day-to-day life? In everyday life? Yes, of course. We use mathematics in cooking. We use it in measuring different weights. Like if we go to the market, we use it to measure the vegetables, the fruits. Also, we use mathematics in measuring the length and breadth of the cloth when we go to buy a cloth. Also, we use mathematics in different things. How has mathematics helped propel humanity forward? You might think of examples involving carrying out scientific experiments, running our economy and democracy, building bridges, houses, and other complex structure, making TVs, mobile phones, computers, bicycles, trains, cars, planes, calendars, clocks, etc. So here only they have given the answers. Mathematics helps us in all these things. Moving further, 1.2 Patterns in numbers. Among the most basic patterns that occur in mathematics are patterns of numbers, particularly patterns of whole numbers. Now we know that whole numbers start from 0, 1, 2, 3, 4 up till infinity. So the branch of mathematics that supplies patterns in the whole number is called number theory. So what is number theory? Number theory is the branch of mathematics that studies the patterns in whole numbers. These numbers is called number theory. Number sequences are the most basic and among the most fascinating types of patterns that mathematicians study. Table 1 shows some key number sequences that are studied in mathematics. So over here in the table, you can see that there are patterns. So first pattern is like 1, 1, 1, all ones. The second pattern is 1, 2, 3, 4, 5, 6, 7, that are counting numbers. The third one is all the odd numbers. This is all the even numbers. This is all the numbers but leaving like jumping 3s, like 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27, 3 to the power of 4 is 81. Like this, these numbers are given. Now there are more questions for you all. Figure it out. Can you recognize the pattern in each of the sequence in table 1? Yes, of course. Recently we have done the pattern. Rewrite each sequence of table 1 in your notebook. Okay, it's like an activity for you all, with the next 3 numbers in each sequence. Okay, so they are telling you all to complete the pattern and to write the next 3 numbers in this sequence. So they have put dot dot dot, and you can write the numbers. After each sequence, write in your own words what is the rule for forming the numbers in the sequence. So you can figure it out. If you are doing the first one or the second one, you can see the rule is counting the numbers in 1. This is odd numbers. If you are writing this squares, this one, you know these are the squares. So next you can write the next following squares. 1.3 Visualizing number sequence. Many number sequences can be visualized using pictures. Visualizing mathematical objects through pictures or diagrams can be very easy, fruitful way to understand mathematical patterns and concepts. Let us represent the first 7 sequences in table 1 using the following pictures. Okay, so over here on the screen you can see the first diagram that I have shown you is it's a triangle. Now you see the second diagram on the screen, you will be able to recognize it's a very basic shape. It's a square. Okay, and this shape it's a rectangle. Okay, and the last shape that I am putting on the screen, this is a circle. Okay. So in table 2 you can see picture representation of some number sequence. So 1, 1, 1, 1, you put just one dot. Then next is counting numbers. 1, 2 dots for 2 numbers, 3 dots for 3 numbers, 4 dots for 4 numbers. Then odd numbers, 1 dot for 1, 3 dots for 3, 5 dots for 5, Okay, similarly, they have put dots for each one. So over here for cubes, now cubes they can make only in square shapes. So for 1, they have put 1 cube. For 8, they have put 8 cubes over here. 27, they have put 27 cubes. So similarly, they have just drawn the pictorial representation of some number sequences. Next, now there are more questions for you. Figure it out. Copy the pictorial representation of number sequences in table 2 in your notebook. So this is like a work for you all, and draw the next pictures for each sequence. So similarly, they're telling you all to draw the next pictures over here of the next numbers in picture form. 2. Why are 1, 3, 6, 10, 15 called triangular numbers? Why are these numbers called triangular numbers? You'll know because they are using the jumping pattern of 3, 3, 3, 3. Okay, next. Why are 1, 4, 9, 16 called square numbers? Yeah, of course. Okay, so square. So 1 square is 1, 2 square is 2, 3 square is 3, 4 square is 16, like that. And why they called cube? 1 cube is 1, 2 cube is 8, 3 cube is 27, and similarly next one. Next, you will have noticed that 36 is both a triangular number and a square number. Yes. So you can see this pattern. That is 36 dots can be arranged perfectly both in triangle and in square. Make pictures in your notebook illustrating this. This shows that the same numbers can be represented differently and play different roles depending on the context. Try representing some other numbers pictorially in different ways. What would you call the following sequence? Now here there is 1, 7, 19, 37. So here they have given these are hexagonal numbers. So 1, and there is a gap of 6 numbers. And there is a gap I think so of 12. Yes, and there is a gap over here. You have to tell me. Mostly it will be a gap of 37 minus 19, 17. So there is a gap of 17. So over here they have said that these numbers are hexagonal numbers. Draw this in your notebook. What is the next number in the sequence? So you will have to find the next number in the sequence over here and draw the figure over here. Now, can you think of a pictorial way to visualize the sequence of powers of 2, powers of 3? So here they have given you homework of drawing the powers of 2 and powers of 3 and to draw over here. So here is a possible way of thinking of power of 2. This is the power of 2 here, 2, 4, 8, 16 like that. Same way you have to write for power of 3.